Hello and welcome again. Today I'm drawing a waterfall for a premium restaurant that is at the moment going, at the moment it's been built, and what we have is we have an opening in in a in a door where the customer wants to have a waterfall. So this is going to be a restaurant cafe premium, and the first challenge is how will the kit fit into this opening. So the customer has sent me the dimensions of it, and also ideas for the water treatment, which is in this case quite interesting because we have a semi-automated system which allows the user, the customer, the owner of the waterfall and his personnel to refill the evaporated water pretty easily by just pressing one button, because there's no connection to the drain. So, but I will talk about it later. First, let me change the size of this kit here, which I have drawn yesterday for another customer. So I will use this as a template. And the first thing I have to do is I have to change the dimension of it. So at the moment it is 1100. So this wall we don't need these markers here. And by the way, in the description of this video there is a link where you can open this 3D drawing in your own browser and then fly through it like I do it here. So in the link of this video, in the description of this video you will find the link. Okay, so first I have to shorten this 1100 millimeter overflow channel to 900, which means we need a marker 200 millimeters from here. Okay, so yesterday I made an error here. This time I think I'm going to make it without errors. So this needs to be 200 millimeters. 200, as you can see in the right bottom corner. Enter. Now I have the new size of the inner element of the overflow channel. What I have to do now is I have to hide the slab and the PVC subdistribution. Oh, so this not what I wanted. So, because I have grouped it yesterday, so first I have to ungroup it. And now I can hide the PVC subdistribution. Okay, and remove these markers. And now I'm selecting by double click the inner element, okay, until it's showing these dots, and now I can create a square surface using the arrow up and then press Control, click left mouse, and now I can create such a surface which will cut the overflow channel. Okay, sometimes it's only creating the frame and not the surface, so I have to mark it again. Now I have a surface. Then I go with the right mouse here and I say merge it with the model. So now it's merged and I can select this and remove it. And I will also select the rest of the, I think you call it remnants, artifacts. Okay, then I have to remove this cutting field too. Okay, escape. So now I have cut down the overflow channel to the length I need. And what I will do now, I will move these side parts, double click, select this one, Control select this and this and this. And now the movement tool, click on it, press the up arrow and move it to the side by 200. And now I have it where I want it. And now the overflow channel is cut to 900 millimeter. Okay, so this marker we don't need anymore. And this one not too. Okay, so I'm saving this now. And if you go to the video description and click on the link, you can open this 3D drawing in your own browser and fly through it as I'm doing it. And you can also see the changes I'm making. And while you watch this video, you can also understand a little bit how to plan a water feature regarding the environment, which I will draw later. First, I will change the size of this kit to 90 centimeter overflow channel, and the bottom tank, it needs to be shortened to 1 meter, so also by 200 millimeters. So what I'll do first is I will select the bottom tank and I will move it out by 2 meters. So I know when I move it back, it's exactly 2 meters back. So, and I do the same procedure here. So first I'm using the ruler, and from the inner ledge of the side part I go 200 millimeters. So I have this marker here. Then I double click on the overflow channel a couple of times until, okay, now, I'm sorry, not the overflow channel, but the inner element of the bottom tank. And now I have selected it, and I'm going to the marker I've set before. I'm using the arrow up on my keyboard, press Control, left mouse, and now I can create this cutting surface. There it is. Then I go with the right mouse on the surface and I say merge it with the model. And now I can select this and remove it. So I have cut down the inner element by 200 millimeters. So this we don't need anymore too. And no, this frame we don't need too. But I have to. Okay, here we go. Escape, and now I'm moving this side part also by 200 millimeters to the left. By the way, there's also a free version of SketchUp, so and I love this program. I'm using it since 12 years because it's pretty intuitive and it allows you to really draw true to scale. So I have moved the side part. And this we don't need anymore. Okay, first I need to select it properly by double clicking. Okay, now it's selected, remove, and that's it. So as you can see now, the size of the bottom tank is 1000. I can move it back to this position before, but first I want to remove this marker here because we don't need it, and this also. Okay, selected, moving tool, click on it, and then arrow to the right and 2000, and now it's back on its position. And now I will cut the skewed plate here. So first I'm selecting it and then I'm moving it out again by 2000. And same procedure here, setting a marker with 200 millimeter less, so I'm going here 200. this is my cutting zone. Then I double click the component many times until the whole thing is selected like that. Then a square surface, anchoring it, arrow up, control left click, and create the cutting zone. Again, I have to make it 2 times to have a surface. Okay, then right mouse, merge with the model, and I can cut out this. Okay, this worked pretty smooth. Then select this, remove it, double click this, remove it, and escape. Okay, this we don't need to. And now I can move the skewed plate back by 2000 millimeters, 2000, and now it's there where it has been before. I have to cut down this C profile by 200, but I will not cut it, I will just transform its size with the transforming tool. All I need is a 200 millimeter marker, so I know where to stop the cut. So I take this position, 200, and you can see here's the end of the marker. So I'm selecting the C profile, selecting the transformation tool, going to the center square and then transforming it to here, and that's it. So now I have it also cut down by 200 millimeters, but not cut, but transformed. Okay, so what we need to do now is we need to move these elements also by 200 millimeters. So it's this one, moving tool, click on it, left arrow, and 200, enter. So now this is in place. What I also want to move is the profiles that are holding the glass. So to do that, I will hide the bottom tank for a moment, because I want to move this and this. Yeah. So I've selected it with a multi-selected it with the control button. Now I go to the move tool, click on it, left arrow, and now I move it to this axis and 200, and now I have it where I want the C profile that's going to hold the slab. I will also move the swimming valve, which is here. But first I will remove this old console, and now select the moving tool, arrow to the left, 200, and now this one is also moved. And it makes sense to mirror it, because the opening of the container is here and the connection to the valve is here, so we have to mirror it. There's one way is to just transform it negatively like that, so it's like -1. No, didn't work. Okay. I have to enter -1. Okay, now I have it. I've mirrored it. It looks a little bit like it changed its shape, but I think it's okay. And now I can unhide the bottom tank. And yeah, here we have the swimming valve. I think it's a little bit too close to the opening here, so I will move it a little bit more. Let's say like 50 millimeters like that. But I think it should move it even further, because that's a little bit too short to create a connection, so we have to move the pump and the valves a little bit more to the left by 100 something, and now we have a little bit more space for the float switch swimming valve to move to the middle. I would say like that, but we're getting in conflict with the C profile, so we have to move it even a little bit further, so like this. Okay, so this will now make the connection a little bit easier to the swimming valve. It looks a little bit different than before. Okay, anyway. We have the float valve, we have the pump, and we have changed the size of the bottom tank. Now we have to change the size of the glass and of the PVC sub-distribution. So let me change the glass slab first. Select the ledge, then use the push and pull tool, and the slab needs to be exactly the same size like the overflow channel, so I take this surface as a reference, and now the slab is exactly the same as the outside of the overflow channel. What I have to change now too is the PVC subdistribution. So what I would like to do first is to determine the middle of the overflow channel. It has 900 millimeters, so it means that 450 is the middle of it. So I'm selecting this corner and 450 millimeter. So now we have this reference point here. I select the PVC subdistribution somewhere in the, and I grab it here somewhere in the middle. I press the left arrow, so that's the axis where it moves, and I anchor it here on the marker, and now I have also the PVC at the middle of the overflow channel. Now I need to shorten the sides, so first I use this cap and I move it around 1 inch distance from the inner side. Do the same thing with the other one. Okay, and now I select the PVC pipe and transform it to, with its length, to the caps. Okay, so now we have the 90 centimeter kit with the 100 centimeter bottom tank. What we haven't adjusted yet is the LED support, but I don't know if this customer wants it, but I will just draw it and then he can decide if he wants it. So I will select this bracket and move it by 200 millimeters to the left. And I will transform the size of the LED to using the transforming tool. Okay, and here's the LED stripe. So that's our kit. And one more thing is this we don't need, and this we don't need too, and I will shorten the rubber mat too with the pull and push tool. Okay, so now we have a rubber below a 5 millimeter rubber below the bottom tank, and we have the bottom tank, the overflow channel, and the skew plate. Everything is now shortened. So I will save it, and if you go to your to the link which I have put in this description of this video, you can open this 3D drawing now and watch it in your browser. And you can do this as long as this live video is running, and I think I will leave it also a few days, and after that you can find these 3D drawings at tendelight.shop. I will have a special area where you can open each 3D drawing project and then take a look how did we do it with all the components. So as you remember, we have this opening in the wall, so that's where the waterfall is going to sit. And so here we have around 60 centimeters. So the bottom tank, it has only 400. What I wanted to say is that these components which are now stored at the side of it, we cannot do this here because the sides are closed, but we have some space here, which is here the free footprint area, which has around 20 centimeters, where a canister and the UV filter and the metering unit can be stored and then hidden below a drywall. So what I will do now is I will draw these walls with SketchUp, and you will be, maybe you're going to be pretty amazed how easy this is, but okay, let me start with this wall here. So I don't have this dimension, but it doesn't matter. So I think it's something like, so if this is 60, 55, then probably this is something like 50, and I'll make this 20 centimeters. Actually, it doesn't matter. The important thing is the space we have here in between. Okay, so I will create a wall here. Take this reference point, and I said 55, and then we have 2 times these 63. Let's go first with the 55. Okay, so we have 550. So that's the length of the wall, and I said let's have it 500. 500 in, or maybe it's 450. That looks rather than a rectangle. So let's do 450. Use the surface tool. Okay, now we have the surface of the left wall, and I use the pull and push tool. Move it up, and I know that the ceiling is at 210 centimeters, 2100 millimeters. Okay, that's the ceiling, and we have to shorten our kit here in the glass slab, but let's first make a component out of this so that it's not melting with other components. So we have the left wall, and let me remove this, and those elements I will just move by 3000 millimeters to the right, so they don't disturb now. And what we want to have, this wall at the right too, so I'll just make a copy of this wall, select it, use the move tool, hold the control key, press the element once, and then press the arrow left. Now I have made a copy, and actually it's exactly 1000 millimeter to the right, so that's that didn't work, did it? So I have to do it again. I have to put this corner here, and then again move it by 1000 to the left. Now I have to put this corner here and then move it to the left by 1000. Okay, now we got it. And I'm saving it. And now we have the wall at the left too. Now I will make it unique, because if I don't do that, any changes I change at this wall will also be here. So I've made it unique. And I will just make it thinner by 50 by 0.5. 0.5. Okay, so now we have a thick one there and a thin one there and a thick one here, but the customer said that that's the front face of the waterfall. So actually we need to change the direction of the water flow, because the front face is supposed to point towards that direction. So in that case, I would just turn the whole water feature by 180 degrees. In order to do so, I will first hide these two. Hide. And this we don't need. This we don't need. Select the whole thing and then rotate it. I rotated it around this X and okay, rotate it. Then I'm going to move it to the center again. So I grabbed rubber. So the whole waterfall is rotated. Now let me have the walls appear again. And now we have to push the waterfall to the back. Okay, and I will align it with this surface, because here in the customer drawing it's also aligned with that surface. Okay, and as you can see, this is quite tight here, because the opening is 1 meter and the bottom tank is 1 meter, so it's like we have zero space in here. But the good news is we still can produce this by 5 millimeters shorter. So I have to discuss with the customer what makes more sense. Because I'm not sure if you can cut out here the bricks. So maybe we are going to shorten this by 5 millimeters so that it won't be an issue to have it put between the walls. And that's why I will I will just make a /995 millimeter question mark, and then we can decide later if we're going to do that or not. So next step is adjust the height. So the height of the opening is 2100, and yesterday I remember it's what the ideal distance between the top of the overflow channel and any ceiling is like 70 millimeters. So I will take a marker, 70 millimeters, and so that's the ideal position for the for the overflow channel's top. So I will hide the glass slab. I will grab the overflow channel here at this level, so that I have it at the right height, and I will align it with this 70 millimeters. And now the distance between the top of the overflow channel and the ceiling, it's those 70 millimeters, which gives us enough space for the hose to move above the overflow channel to the PVC subdistribution. And now I will show the glass slab again. And shorten it. So first I will select the slab's top ledge, use the pull and push tool, and okay, that's a little bit, but it's possible. Okay, so until here, as you can see in the right lower corner, it's 460 millimeter. I want to push it 5 millimeter further, so I will go 465, so that I have this 5 millimeter gap here. And now I have the slab also in its place and in its right size. So, and now it's a pretty interesting scenario, because the customer told me he cannot mount the overflow channel to the top ceiling of the opening, because this is a kind of a fire protection material that cannot be drilled in. And I said, yeah, it's no problem, because you can mount our overflow channel system also to the sides of the wall, which I have to figure out now what the easiest way would be, because we have these multifunctional brackets, and usually I really love to have these connected to the ceiling with a thread bar, but we cannot go to the ceiling with a thread bar. So what we could do instead, I think that might work pretty well, is we can use a C profile. Now I'm getting a little bit excited. I love these C profiles, and maybe those are going to be very, very handy now. So I'm going to Control C, the C profile, and Control V, enter it here. Okay, we have the C profile. Then we have to turn it around by 90 degrees. And I will mount the C profile to the sidewall surface. So I mark the ledge, I go with the arrow, and I take this surface as alignment. So as you can see, we have now the C profile here, and unfortunately it's covering these holes. So but there's a workaround, because these C profiles, they are 36 millimeters. And there are other C profiles, they're thinner. So I have to go to the Word shop, and I go Varifix. Montage. Schiene, okay, it's this one. No, wait, they have the 26 by 18, it's a very thin one. And then there's another one, it's a flat one. 41 by something. But I think this one actually should do, because we don't have so much weight on it. So it's 26 by 18. Okay, so I will just transform that one to those dimensions. This is 36 by 36, so I have to, first I have to right click and make it unique, because otherwise I'm going to transform these brackets to these profiles to okay, now I have made it unique. Let's see if it's really unique. I change it. Yeah, the one stays. Okay, so now I can change its size to 26 by 18. 18 was the height. So I take a marker with 18 millimeters and I transform it to 18, and its width was 16, so I take another marker here, 16, no, 26. 18 was the height and 26 was the length. Okay, so 26. That was lost. Okay, here's the marker, and we transform the whole thing. Now we have it. Okay, and as you can see now, our profiles would allow to access these holes. It's tight, but according to this true to scale drawing, it should be possible. So because now comes a super cool thing, because these brackets here, we'll just take it, make a copy, and now I will paste it here. I will make it unique, because otherwise the other one is going to be changed. And what I can do now is we can have this bracket well, we cannot yet. So I was thinking we could mount it like that, but it doesn't make sense. We need to use another bracket that allows us to work with the thread bar. And yeah, I have to think a little bit, because what also can be done, and maybe that's the solution, let me check, because that's why we have so many openings here. We can use this bracket, but as I'm talking, I think I have another idea. I like these C profiles because, as you have seen, we have a kind of a brick wall, and drilling into brick walls and putting screws in it, it's really hard to work precise. But if you have, so drilling only 2 holes, it's, from my point of view, almost impossible as at a specific location, because if it's between the bricks, it won't hold. But if you have a C profile, you have multiple drilling options in order to have the C profile placed precisely. And then if you have an inlet, then you can, you're super flexible regarding the position of the overflow channel. So as I'm talking, I'm just realizing that it's probably easier than I thought if we use the original bigger C profile from before and just have it mounted below. So let me check this. So I'll take it again, take this one, and then paste it here. Because, and then let me just make it unique, otherwise it's going to be connected with the original one. So if we move this one a little bit lower, like this, then actually then these holes here uh, they would sit pretty suitable, so we don't need this bracket. So let me just remove this one for a moment. Yeah, so that's actually going to work pretty nice because we can have bolts here, and then we are also going to be able to adjust the height. So actually this is going to work pretty nice. It means that we would need to move the C profile a little bit to the middle, well, let's say by 5 millimeters from the wall. So we then we would have exactly the middle of these holes, and we still have enough space between here so that we don't get in, so we don't touch this area here, because here we can have some vortex and then the water could go around and here, but as long as we have here, yeah, 5 millimeters something, the water will not jump over there. So the only challenge would be to mount this C profile turned by 90 degrees, which means you cannot drill it into the wall here, so we wouldn't need a console. And but what's also possible is to put a wood here, which is 4 by 4 centimeters, for example. I think that's maybe the most easy way, because you can then mount the wood by screwing from this side through the bricks. Yeah, or what you can do is, no, this I don't want. You can have a piece of wood. What happened here? You can have a piece of wood down here, 40 by 40. So let me just draw it 40 by 40 millimeter, make it 30 centimeters long, create a component, and then move it below the C profile and to the wall. Yeah, so this is how I would probably do it. I'm not sure if it's the best idea, but that's what I think it's makes sense now. To have a wood mounted to the inner wall. Which is 40 millimeters. And on that wood, then we can mount a small piece of C profile, which then has these inlets with the bolts, and those bolts are then going to be flexible. Because if we work only with the wood, then we don't have this flexibility of moving the inlets back and forth. So the wood would only serve as a console for the C profile. What we could do, but I'm not sure if it's so beautiful, we could also use these brackets here, because they're adjusted to the C profile system. So we could use this bracket, but then again we have the challenge to have this bracket fixed to the brick wall. So even if you use this bracket, which is made for the C profiles, so it would sit here, and I will hide this for a moment. So that's another way to hold the C profile instead of the wooden bracket, and I think that's maybe even better than the wood, because this one is quite flexible with this long hole, so you should be able to drill into the brick somewhere to have one of these mounted somewhere here and the other one somewhere here, and then the C profile is going to be pretty nice in place, remembering that we have to use this 5mm distance to the wall so that the middle of the C profile aligns with this mounting holes of the overflow channel. Okay, so I think that's a pretty stable mounting system. So let me just duplicate this one and put it to the other side. Here, and then move the whole thing a little bit, this and this and this to the left. Because what we haven't determined yet is the position of the waterfall, so of the slab. I would say probably it makes most sense if we have the slab in the middle of it. So let's see if, the customer has only determined the position of the bottom tank, but not of the slab. So luckily we are flexible. So what I will do now, I will just push the slab towards the front, but as you can see, we don't have so much space because the pump sits here. The pump has 14 centimeters, so that's actually the minimum we need for the pump. So let's see how much we can move the slab. So first we have to mark the 14 centimeters from this bending. So I go here and I say 140, which is 40mm. So that's our marker for the ledge of this C profile, because that's where the pump needs to pass through. Okay, let me measure the distance between that ledge and, so let's say it's somewhere starting here and we want to go here. How much is it? No. 8 centimeters. So that's what we can move towards the front, and that's what I will do now. I will move. Okay, first we have this, and 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 this, this, and no, that's not working. Shit. Because this is a group. Okay, but that's quite an operation. So moving by 8 centimeters. Okay, let's first hide this and this, and we will hide this too. We don't need that. And I will first move the slab and the overflow channel by 8 centimeters. This direction 80mm. Okay. And now we have to move the rest. let's hide bottom tank and ungroup this. And now we move this, this, and this, and this, and this. This and this and this. So I will group those and move them by 8 centimeters over there. And now we have to move this to I will group this too because maybe I have to change this later. And I will move it by 8 centimeters over there. Okay, this one is left. Okay, so we have moved. That's the 8 centimeter marker. And we can now unhide everything again. And now the pump will be, we have enough space in order to get the pump in and out here. So that would be the position of the slab. And it looks like it's quite in the middle of the whole thing. Yeah. Well, we can't go further anyway, so what we could do is we could place the pump here, which maybe makes sense because actually this area here, the footprint area, is where we want to store the canister and metering unit and inline filter, etc. So the main access area is going to be from the back, which means it would be better to have the pump and all the connections on the other side, because then we don't need to access here from this side. So let me check the middle of the 55 centimeters. It's 250 and 275 millimeters. Okay, that's the middle of the opening, and our slab is actually it's too far over there. So we could even go back by 2 centimeters if we want to be in the middle. So that's the front of the slab, that's the middle of the opening, and that's, yeah, we could go back by 3 centimeters, and then the slab would be in the middle. Thinking. Well, I think then maybe it's really better to go back 3 centimeters, and we have enough space here, because yeah, that's not enough for the pump. And yeah, I think it's more comfortable to access the pump and the swimming valve from this side of the opening. So what then we would need to do is move everything back by 3 centimeters. So let me move it as by 3. So I'll go here, 30 millimeters. Don't need this anymore. And I have to move the other parts too. So let me just hide the walls. And this. No, let's first make this 30, then those. This one. I think that's all of them. Okay, now show the rest. Yeah, then it's not too tight in here. And okay. Good. So then we have a 63. Yeah, he says plasterboard. I think that's the drywall thing. What we have. Yeah, so that's from the brick to the front of the drywalls. I will also draw this so we have a reference. 63 millimeters from here, and then surface 1. So this is the 63. For the drywall cover. Okay. Yeah, I'm sorry I cannot think loud because we have thinking about multiple things. The one thing is that we have a hose that now needs to go from here up to the ceiling, and I spoke with the customer and we said we can hide the hose here in the drywall. So I will not draw this because that's not such a big thing. It means that the hose from the pump goes up and then it goes to the left or to the right side, depending where this cutout in the wall will be for the hose, and then it will be hidden in the wall and it will exit the wall somewhere up here. And then you can connect the hose with the PVC sub-distribution. I think this doesn't need to be drawn right now, but what we need to draw is we need to have the dirt filter inside here, which has to be a small model. So I will just take this and remove this one. And I remember it was like 3. So I move it into the bottom tank. And so over there we have the swimming valve, so no space for the dirt filter over there. So we would need to store the dirt filter here. but it's still a little bit tight because this dirt filter needs to be changed like every 3 or 4 months, which, yeah, and the harder it is to change the filter, the less often it will be changed. So we want to have this changing of the dirt filter as easy as possible. So putting it in here is it's not really elegant. So I think what we need to do is we need to put the dirt filter 2 in this area over there, in this footprint area, because we have these 20 centimeters, so it's not a question of space, it's actually a question of line of piping, because we have the pump and we have the hose that is going up to the overflow channel, and we have a T, and from that T we have another smaller hose going to the dirt filter, and then we have to go back from the dirt filter inside of the bottom tank. Because the pump is over there and the filter is over here, and we don't really have so much space at the sides for moving hoses, it's a little bit a challenge to have this filter hose come to this side and then enter the container again. It's possible, but it's, as you can see, it's a challenge because we don't have so much space. We only have 5 centimeters here. The hose, it has only 20 millimeters, so it's going to be enough space for the hose to pass over here, but it's tight. It's tight, but it's possible. Okay. Yeah, it's possible. So what we will have to do is we will have a small hose going from over there. Actually, this one can go, the small hose, we don't have to pass at the sides. We can go with the small hose below, because down here we have a 5 centimeter gap. So we can go with the filter hose, we can go below the glass. Yeah, that's what we're going to do, yeah. So we don't have to travel with this filter hose here at the sides to the back, so we will travel to the back by going below this C profile, by going below the glass, which is, so we have a glass, we have a gap here, which is in fact 36 or 40 millimeters, but that's enough because this hose, which is going to the filter and back in, it's only going to be 23 millimeters. Okay, so that's the filter hose, which means that I can draw this later regarding the way of the pipe. There's one thing that I will draw now too, it's the covers. A basic idea on how to create the covers here at the bottom tank and at the top. Yeah, but what I'll also do, I will place the canister and the metering unit in that space. So let me take those and move them over here. Okay, I go on these crosses, I can rotate, and I will have this canister move to the edge over here. and it has something around 14 centimeters, so it will fit into this gap. And now we have these 15. Actually, the customer told me it's a 20 centimeter gap, so we will have space for the canister. And then we can go with the hose of the canister. We can go over there and mount the hose of the metering unit in one of these holes of the console, which is also holding the float switch. What we also want to have here is an inline filter, but this is something the customer will have placed himself, because there is a water softener in the house, and the customer has found a additional inline decalcifier, and that one is going to be stored here too. And then together with a Gardena time valve, he will press a button, and then the valve will open for a determined time and refill the evaporated water. Okay, but this is maybe something for another tutorial video. So what I'm going to do now is I will just create a basic setup for the covers we need. So let me do the 63 millimeters over here too. Okay, and pull it up to the top, make a component, the same over here. Make a component and save it. So when you click the link in the description of this video, you can open this whole file in your browser and fly through it. Okay, so we have now the 63, and what we will have to do is we will have to go with the hose from the pump inside the side wall, and which means we need, I would say like 5 centimeters here in order for the hose to enter the wall. So the top of the cover needs to leave 5 centimeters space below it. So let's say the bottom tank is 30 centimeters high, and we want the bottom of the cover at 35 centimeters, so that we have enough space for a hole here. But I think it's a little bit too tight, so let's just go 2 centimeters higher, so we have 7 centimeters space between it. And then what I recommend is to leave 2.5 centimeters towards the glass slab. So we need an anchor with the 2.5. So let me just hide this and hide this, and create an anchor with 25 millimeters. So I know how far I can go with the covers towards the glass. So I will just measure the distance first. So 312 millimeters. Okay, 312. As it's drywall, I would just give it a 3 centimeter thickness, so make it 30, or maybe it's a 63, so let's go with these 63. So the one cover could look something like that. Create a component, and then of course we would have one here at the front, but I think it's probably enough to just move the top, to make only the top removable. Okay, so this would be then the front part of the cover. So we have these 2.5 centimeter distance towards the water film, and let's show the side wall. And of course the distance up here is the same, so actually we can copy this element by Control left mouse and then move it up. So the other element at the top cover, okay, as we can see, we have to consider these brackets as a stopper. So we won't go higher than, okay, let's make it 25 only, so we have some distance between here, which is 7 millimeter. Let's make it even more. Let's go 3 millimeter lower, so we have 10 millimeters here. Otherwise, we would hide too much from the waterfall. Okay, and then we would have this one. We can copy too. Oh, didn't copy, so. Move it up and make it unique and put it in place and make it smaller. Okay, so now we have a cover from the front, and actually we can do the whole thing at the back too. So what I'm going to do is I will just copy all these parts. 1, 2, 3, 4, 5, 6. Use the move tool, press Control left mouse and then move it there. Because on the other side we have also these 63 millimeter plasterboards, and I will attach it here to the wall. So actually those two covers stay the same, and all I would need to do now is just move these two towards the glass slab and see what it looks like then. Theoretically we would have again the 25 millimeter, but let's see. Okay, let me first save it. And as I said, you can watch this 3D model if you click on the link in the video description, because that's the cool thing about SketchUp. You don't have to have the app, you just can open such drawings in your browser. So please click on the link and let me know if you like it. And I will, in the meantime, check. Okay, the front is here, and now let's see how The covers from the back are according to the glass slab. I was expecting to have the exact same distance, but somehow it doesn't. It's not a lot. Actually, what I usually do is I only have 1 centimeter at the dry side, so it looks like it would fit anyway, but I wonder how it's gotten there without me having measured it. So let's see the distance between the glass and this cover. It's 17 millimeters, okay. 10 millimeter would do. So, but in order to make it look more symmetric, I would just make out of the 17, I'm going to make 15, which means I'm going to go, what was it, 17 millimeters is the distance? So I have to go 2 millimeters towards the glass slab. Now this is 15. Okay. But maybe I have changed. Was it unique or was it not unique? So let me go back. Okay, now it's unique. Let me check. So this one is 314. 314. So if I change this one by 2 millimeters, it's 316, and the other one stays. Okay. And this one is 314. We have a conflict here with the bottom of the overflow channel, so we have to move it down anyways, but let me first make these 2 millimeters here. Okay, this make it unique. And 2 millimeters here. And save. Okay, now we have to move these two lower because they're touching. Anyway, better because then we have more space for these brackets. So until here we would have 0 distance to the overflow channel and 20 millimeters. So let's go 40 altogether. So we have 20 millimeter below the cover and the overflow channel. Let's give it 10 millimeters more so it's not too tight. So let's go another 10, and now we have 30 millimeters here, and now it's covered nicely. These upper parts, they need to be bigger, but we can do this pretty fast by just transforming them. Saving and okay, that's it, I think. This is the basic planning drawing for my customer, which now shows that the 90 centimeter kit would fit in, and the creation of the covers is relatively simple. And only thing is maybe to add here a little bit, but I think I would maybe even leave it like that because, yeah, it's not a big design advantage to have to close it here. And I think, yeah, one can leave it like that. So I'm saving, it's saved, so we don't need this anymore now. And you can watch it, my customer can watch it now in 3D if you click on the link below. And thank you for watching, and if you like it or if you have questions, please leave your questions in the comments. Please subscribe to my channel. Please go to my online shop. And if you are working with SketchUp anyway, I would be glad if you contact me because and if you also want to make indoor waterfalls for your customers, I would be glad if we can work together because I have quite a number of drawings and I would be glad if somebody would like to help me. And the good thing is that when you help me doing such drawings, you learn how to build automated waterfall systems. So yeah, so if you love SketchUp like I do, please contact me, and thank you for watching.